In this recording, we will be doing Amitrack ridership example, and we will be building multiple models and see how it goes. First of all, I just copied the libraries that we need, Sybil, Tidyverse, Fable, Slider. Also, I loaded my data as we did before. Then I changed it to Sybil. Our index is year, month. Also, we can plot either with ggplot, geomline, or autoplot, whatever you prefer. This is the Amitrack. After that, we partitioned the data. We left the last 36 months, 36 or whatever, yeah. Then let's see. Yep, 36 observations as validation. So the first one is training, second one validation, filter index from 2. From 2 we have dot because to the end of the data. After that, the first thing we are going to do is we are going to build, number 1, linear trend. So just linear trend, okay? Linear trend on the training data. So we're going to call it train.linear model. I'm going to access the train data. Then I'm going to pass it to the model. Remember that we're using model. This model now is going to be time series linear model, TS. So what is my response variable is ridership. Then I'm going just to have the trend, which is T in this case. That's it, trend. Just give me the trend T. It's like T. This is exactly like T. So we build the trend LM, train LM, okay? Train LM. So this is the linear trend. Let's plot this one. Let's plot this one. So plot the trend on the training data. So to do that, we are going to pass the train to our autoplot. First of all, I would like to do the ridership. So this is ridership only, right? So I'm going to pass the geomline to this geomline. Geomline is going to have different access to a different data set. So it's going to access different data set. So what is the data set that I'm going to take the values from? Because we are going to plot the fitted values. Let me just show you this. If you type train, you will be getting nothing here. It just shows you the train that, hey, this is a list of things. This is the model. So how to access to the table? We just type fitted train.lm. So fitted trend, it gives you access to that symbol that we have here, which is we have the model, we have the month, we have the fitted. So my data set now is going to be fitted train.lm. I would like to plot the fitted column. So this is going to access to be in y-axis. Okay, so this is the aesthetic part. So geomline has an aesthetic part. So y is going to be dot fitted. After that, I'm going to specify the data set that I'm going to use for this, which is train.lm. You can specify then the color if you like. So the color you can add blue, let's say, or red. Also, you can specify the size of the thing. So let's say 1.2, whatever. So this is the fitted line. After that, I'm going to add the scale. So just to show that the years down there. So scale X year month, as we did before, data breaks. Just I would like to see 1 year or 2 years. 2 years. Also the labels equals, they have to be, just show me the years only. So it shows the year every 2 years. I'm going to make it 1 year. Also, I would like to change the labels, labs, X equals just month, or not month, time, sorry, time. So this is our plotting on the training data. So let's do forecasting on the validation. Validation. So forecast, we are going to use the same function. So I'm going to call it forecast linear model. Forecast linear model. Forecasting from where? So I'm going to access the training. Okay. So forecast H equals 36. So we are forecasting the next 36 periods. If I want to plot both of them, let's plot both of them. Plot both training and validation. So first of all, I'm going to access my Amitrack data, time series. Then I'm going to pass it to the autoplot. Autoplot is going just to give you the ridership. Just I'm going to plot the ridership. After that, I'm going to add 2 geom lines. one for the forecasted values, one for the training. So I'm going to do the geom line, the same as we did before, which is going to be aesthetic, y equals dot fitted. Then the data is going to be taken from fitted train LM. We can do the color to be blue as we did before. Also, I'm going to add another geom line for what? For the forecasted values. Now the question is FC. Okay, let me look at this. FC dot. This is a forecasted linear model. This is my data set. So my data set is not going to be changed. However, this is my fitted value, the mean. So dot mean is going to be my aesthetic. So aesthetic is going to be y equals dot mean, comma, data is going to be the same guy, FC dot. Also, we can do the color to be red. Let's change the type of the line type. Line type to be dashed, let's say. Okay. Also, we can add the levels, and this is the thing. So this is what exactly we have done on the forecasted, and look at the difference between the actual values and the forecasted values. And you can add other stuff as we did before, scale, X, year, month. So we have here date breaks equals 1 year, then date labels equals year. Then we can again change the lapse X equals time. If you look at the model, I mean, if you would like to report the model or look at the accuracy, we can do this, but I'm going to do this at the end because we know that this is not the appropriate model that we're looking for. Let's just jump into the next one quickly. So the first part we did is build linear model. Let's do exponential trend. This is linear trend. Now let's do number 2. Let's do exponential. Build an exponential trend. Okay. We will be doing the same thing on the training data set. So we are going to train.lm. Okay. Should I keep the same name? Okay. Let me call it linear model. We call it EM. Okay. Exponential model. So train, I'm going to pass it to what? To the model again. Then, okay, the question is, can we do both of them at the same time? Yes, we can do. We can do both of them. Let me do both of them. Let me do the linear trend and the exponential trend. So let me call it train trends or linear exponential model. Okay, LIM. Let me call it LIM. The first one's going to be linear. The second one's going to be exponential. Let me do the first one first. So the linear is time series linear model. We are going to pass ridership to be the response. Then the trend is going to be our. I'm not changing anything. I'm just keeping the linear model. Then I'm going to compare this with the exponential. So this is comma. Then I'm doing the exponential. Mixing up. Oops. Exponential. So I'm going to call it exponential. TSLM, the only change I'm going to do is ridership is still my response variable, but this is going to be a trend. The only change I'm going to do is, remember, we are not passing ridership as an output. To be linear model as a logarithmic, we are going to call it log ridership. Okay, log ridership. Exponential. So this is I guess I should have, this is here. Here we go. So this is our train lim. Also, let's do forecasting. So forecast validation. So forecast lim trends. I'm going to use the model that we built, train lim. I'm going to pass it to forecast lim trends. Okay. Let's plot them now. So the first one is going to be, I'm going to pass Amtrak as usual, Amtrak time series to our ridership, to our autoplot, just immediately autoplot for the ridership. This is going to draw the ridership, the original one. Then I'm going to add geom line. Now the trick is going to be this. So geom line, I'm going to draw the training data. So the aesthetic is going to be y equals dot fitted. We have no issues with this, comma. The data is going to be fitted train dot lim, right? So I have to say something here, but just a second. Let me add. Someone's going to tell me what about the color. So let's just explain this. So let's go first to the console just a little bit. Fitted train dot lim. Okay, let me echo it here. Fitted train lim. So I'm not sure if you see the windows. Anyway, so in this model we are going to have actually it doesn't if you look at number if just go to number 2, 3. Let's go to number 6, 25, 24. Here we go. So the first few lines, the first few rows, we are going to have actually 122 or 122. First 122 rows, we're going to have linear model. Next 100, 200, 120. After 122, we're going to have the exponential model. So both of them are at one time series. So that's why I'm going to draw both of them, right? So the color, I would like to add the third dimension to be the color. To draw two different lines, geom line, I would like you to differentiate them by colors. So use this to be the dot model. So again, why is that? Don't get confused. I'm going to delete this now. This is dot model. So go to the dot model, and when you draw the lines, make them pair color. So I'm going to delete this now. So if I draw this, dot model not found. Hey, let me add the auto layer first. Let me add the forecasted values, then I see. I don't know why. Auto layer. We use auto layers, by the way. We use auto layers. Auto layers is just a quick, neat function to access the forecasted values. I'm going to take off the level. The level is remember, the level, we talked about this multiple times. The level is the prediction interval. Let me take line type to be dashed. So let me do here color dot model. I see where is my mistake. Okay, listen to me. Because this is a huge mistake. I am adding the color as a color outside the aesthetic, which is completely wrong because I am mapping. Now this is a map. It's not just a color. I'm doing mapping. So I am mapping the model to the color because it's a mapping. It should be inside the aesthetic. I hope that this is clear now. Now this must work, by the way. So here we go. So now we have both of them. I have the geom line that shows the training data. Then we have the auto layer that shows the forecasted values. Just another way of showing things. Auto layer is faster compared to the geom line. Also, we can show the we can change the line type. Also, to change the line type, you have to do it inside the aesthetic because you are mapping the line type has to be, let's say, based on the model. Again, no need for this. Based on the model. So give me the color based on the model. Map the color to different models. Map the lines to different models. So we should have the two different lines. And look at them. We have two different lines for both of them. And as we've seen in the lecture, we don't have a big difference between both of them, exponential and the linear trend. So in this case, what we have to do, we have to look at the polynomial trend, which is number 3, polynomial. And we know that it's second degree polynomial. The question is, do we need to do all of this? No, we don't need to do all of them. Because we know from the beginning that we can do polynomial trend, and we can do from the beginning, we have to add the seasonality, but now we are just trying, that's it. So let's do train.q model. Okay, we're going to pass the train, then we're going to do the model, time series, linear model, then we're going to have ridership, tilde, then we are going to have the trend, and we're going to have the square plus. We're going to add the square. The square in R is I. Trend, then we square it. Be careful. Square the trend. The trend, parentheses, is like the T. Okay, so this is our squared. Do forecasting on the validation now. Forecasted underscore. We use dot then underscore. This is not unique. We should have a unique naming convention. So QM. So I'm going to pass the train QM to my forecast. H is 36. We did forecasting. Now let's plot them. So let's do both of them, okay? Let's plot both of them. I'm going to pass Amtrak to auto plot first, ridership, plus I'm going to add geom line, the same thing. My data is going to be fitted QM, and my aesthetic is going to be y equals dot fitted, and again the color. Now the question is, if I keep the color inside, does it make any difference, or outside? Remember what we did before. Where is it? Here we go. So you put the color outside because we're not matching the color to anything. The same thing here. I'm not mapping anything to the color. So if you keep it inside and outside, try it and see how it goes. So this is the graph of the training. There's something wrong. What was that? Oh, we have to add another graph for the forecasted value. I'm going to use auto layer. Again, auto layer is a neat way to add the forecasted values. Also, we can still use the geom line as we did before, right? Level is null. If you did not put the level is null, it's going to graph the level, which is 90% or 95%, something like this. Line type to be dashed. Again, we can add the other stuff, right? So this looks much better than before. We have the mapping here. We don't want this. So I'm going to take it out. I'm going to take this out. If I take it out, we don't see the maps here. Okay. So if I take it out, as I said, we will not be seeing because we're not mapping the color to any models or to any other dimension or variable. That's why it's keeping it out. The aesthetic is maybe better option in this case. Now, because we believe that this is a good model, we can, but still not 100%, we can look at the report. We just can look at the report. We can use report function for the training to look at how the model does. So it gives you the intercept. These are the estimates. These are the betas. This is beta note. This is beta 1. This is this is beta note, beta 1, beta 2. Yes. So the equation is going to be YT equals 1895.88 plus negative 6.6 T plus 0.05656 T squared. And we have here is adjusted R squared, or R squared about 15%. So the model does not explain a lot of variations of the ridership. So it's very low value. We don't look at, as I said, we don't look at these right now, the significance. This shows that the betas are significant, and shows the V value here is significant as well for the statistic, but we don't want to look at this because we are missing still the seasonality here. Also, we can look at the accuracy if you would like to look at the accuracy of the forecasted QM comma validation. So we can look at ME, which is negative 95. So on average, the forecasts under predict by about 100, by about not 100, it's by about 95, 100 or 95 riders. So we are under predict on average by about 95 riders. RMSE is 186, so the average, which is the root mean square error, which is should be higher than it's better than other measures. So it's not enough now to look at this because we know that this model is not our model that we're looking for. These are NaN because we're dividing by zeros or so many missing values. In this case, we have zeros. So we don't worry about the report right now. Now let's move on to building the last model, which is model with seasonality. I'm not going to just, okay, let's do it by scissors then, both of them. So model with seasonality. This is number 4, I guess. Model with seasonality. So let's do train. It's going to be seasonality model SM. Train model ridership. I'm going to pass it now to the season, simply to the season. Okay. And I'm not going to report anything, but I would like to look at the report. So for you to see report, train.sum. So look at the report, year 2. Look at how many dummy variables we have. This is year 2. This is the second season. This is 2, 3, 4, 5, 6, 7, 8, 9, up to 11. So the first one is the reference value. Okay. Look at how much this model explains the variation of the ridership. It's much better than the trends, and it's clear because we have strong seasonality in this data set. But this is not enough. So I'm not here to just talk about this one. We can graph it. We can graph both of them. We can graph. Let's plot this. And we can plot this is additive seasonality, by the way. So I'm track auto plot. We have geom line, fitted train seasonality. Also, my aesthetic is going to be y equals dot fitted. So the color is going to be out in this case. Also, I'm going to do the auto layer for the forecasted seasonality. Did we do forecast? We did not do forecasting yet. So let me forecast. So I'm going to call it forecast.season. I'm going to pass the train.s to forecast. Okay, let's run this. So sm now, level line type equals dashed. Ridership, not found. Here we go. This is much better than before. This is the model that we have built in red, and this is how the model does on the unseen data. And as we said, it looks that we are under predicting or forecasting this. So let's do the following. Let's plot the residuals. So train the residual first. Okay, let me first look at train dot season. Let me look at the fitted first. So this one doesn't give me, it does give me the model month fitted. There's another function we used the other day is called augment, which is a very well-known sum. So look at augment. Augment gives you a lot of things. Give you month, ridership, fitted, residuals. So we know the residuals. So what I'm going to do is I'm going to access this symbol and just take the month and residuals. I'm going to keep these two guys. So I'm going to look at the train residual, augment, train.sm. I'm going to select the month and the reside. I'm going to have these two guys. Okay, I'm going to do the same thing with the validation residuals, but I'm going to calculate the residuals. It's not big deal. So I'm going to call it valid.resid. So what I'm going to do, I'm going to go to the validation data set. Then I'm going to mutate dot residual. I'm going to call it dot residual. Then I'm going to subtract ridership minus the forecasted value, which is the mean value. So this one is the forecasted validation value subtracted from the original ridership. It's going to give me the residual, right? Then I'm going to select again just the month and the dot resid. So valid resid, look at valid resid. We have month dot resid, the one that we calculated, okay? After that, I'm going just to put them together. I'm going just to combine them, all residual. Just I'm going to bind rows, right? Bind rows, put them together. So mutate train reset, train.reset. I'm going to call it to training or train. Also, I'm going to add another column, which is from the valid residual, and it's going to be validation. I'm creating another column, all reset. I'm adding them underneath each other. One for training, I'm calling it training. The other one, I'm calling the other one to be validation. That's why I'm using bind rows. I'm putting this guy underneath it, the other one, and each value is going to take either the name training versus validation. After that, I'm going to plot. So let's end. So let's plot. So if we can say here, we can say put residuals together. We can now plot, because I said plot, let me plot it here. Plot. So we can ggplot immediately, just all reset, all dot reset. Aesthetic, what is going to be my x? My x is going to be month, and the y is going to be the residual, dot residual, right? Now the color is going to be the type. Remember, we have a third dimension. This is my x, this is my y, and this is my type. The color, my color, okay? This is we're gonna add geom line. This is not enough. Geom line is the one that's it. Here we go. Also, I can add the horizontal line, the 0. Let's add the horizontal line. Geom, not vertical, horizontal. Or edge line, okay. It's going to be just y-intercept, y-intercept. Y-intercept equals 0, period. You can make it dashed. Line type to be dashed. You can choose the color, black. Here we go. Now we can look at this. We can look about the residual. We see that we are missing the trend because we have a behavior. So the residual is not random. It's not random. It takes a pattern. There's a pattern. Because it takes a patterns, we have to do something. To do something, we have to add the trend. Excuse me. So we have to add a trend now. So let's do that quickly. So regression with a trend and seasonality. Trend seasonality. Okay. Model TSM. Train model TSM. Ridership tilde. We're going to add a trend first. We're going to add the square of the trend because we know how this guy behaves. And we are going to add season. This is after that we're going to do forecasting. I mean, we are just repeating what we have done. So forecasting, we're going to forecast TSM. I'm going to access my model that we have built. Then we do forecast at 36. Then let's plot this. Let's do plotting. Amtrak TS time series auto plot ridership. We're going to add geom line. Data is going to be the fitted train.tsm. Aesthetic is going to be y equals dot fitted. Then the color is going to one model to keep the color outside. And we're going to add an auto layer forecasted.tsm. The color, keep it, let's say blue. Then the level is take it off. If you do not, try without the level and see how it goes. Then you add the labs, etc. Here we go. So we have a really good model compared to others that we have done. So if you look at the residuals, I'm going to keep the residual part for you to redo it again. Just repeat what we have done before and compare the residuals. The last thing I'm going to do is just report train.tsm, the significance. Look at how the model does. No, the adjusted R squared because we have too many variables. So this is 8%. So the model explains 8% of the model of the variation of the ridership, which is really good. Also, we can look at the accuracy of that, how the model does with the TSM on the validation set. Then we look at the values. And there's one value that we would like to look at, and that takes me to this is the one. ACF1. ACF1, by the way, this is a good value. MAPE. MAPE, that means, about 6 to 7% forecasts are off, on average. So, which is good, which is solid. So the forecasts are off by only 6.6%. And it's a respectable number. However, ACF1, and this is going to be our next topic, it's 0.7, which is big. So the residuals still have heavy, something we call it autocorrelation. So we have an issue here, ACF1. So that's still an issue, and we have to deal with it. This is going to be our next topic. Thank you.